Hello viewers on YouTube. In this video tutorial, we're going to consider going through the process of finding the variance and that of the standard deviation. And along the way, I'm going to show you how to find what we call the coefficient of standard deviation and the coefficient of variation. So first and foremost, we have to consider the variance. Variance is split into two. We have the population variance and that of the sample variance. And for group and ungrouped data, the formula is different. So let's talk about the formula first. For the population, which I will just write as, okay, let me write it full. For the population distribution or for a population variance, the variance is symbolically denoted as sigma squared. And for ungrouped data, it's generally have up to 4 formulas that helps us to do that, and these are the formulas. The first one is that the sigma squared is equal to the summation of x minus x bar all squared and entirely divided by n, where n is the summation of the, or let's just say the frequency of that distribution. You understand? Now, for those who might be wondering what x bar means, x bar means the population mean. Keep in mind, population mean. Though population mean and sample mean are not really different, though in terms of visual illustration and formula, they are different, but they provide the same result because the formula is still referring to the same thing. But the symbol we use to denote them is different actually. That's what we are trying to say makes sense. The symbol is the other thing that makes the population mean and that of the sample mean to be different. Perfect. Now, the second formula that helps us to find the population variance of an ungrouped data is this, that the summation, let me do that again, the summation of the square of the distribution individually, then minus n, which is the number of the data, okay, then multiplied by x bar all squared, then entirely divided by n. So that is the second formula that helps us to find the population variance. The reason why I'm giving these formulas, the alternative formulas, is all because some lecturers, when the statistic problem courses you are taking involves a multiple choice exam questions, they won't give you the distribution to save time. You understand? They will just give you the sum of the square of the data, then they'll give you the value of n and x bar. Now you might be wondering, how do you want to find the variance in this case? So this formula can always help you to do that. So each of those formulas is very, very important as they have where they are applicable. So it's important to know that. But if the distribution is listed out or if it is given, then this one is fully recommended to always use. Now the third one, as I was saying, is this. Is equal to the summation of x all squared minus the summation of x, then everything all squared. This is divided by n, and entirely is divided by n again. So this is the third formula, and that helps us to find the variance of a distribution. Now, what about the last one? The last one is simply equals to the summation of x all squared divided by n, the minus the summation of x divided by n, and entirely all squared. So this is the fourth formula. So just take note of all those formulas, know when to use them. They can only usually be used, like for this one, it's applicable or it's recommended when the summation of x squared is given and x bar is given, likewise the value of n. While this one is also recommended when these 3 values are given, and for this one, same thing applies when the 3 values, okay, when summation of x squared is given and summation of x is given. Same thing applies to this one. When summation of x squared is given and summation of x is given, likewise the value of n. While for this one, if the summation of x minus x bar squared is given and the value of n is given, then you are good to proceed on using it. But if at all the distribution is what is listed out, like it's what is given to you entirely, then this first formula is absolutely recommended. Perfect. And that is the formula that helps us to find the population variance of an ungrouped data. Now, what about the group data? What is the formula that helps us to do that? For the group data, there are just some slight things you need to change. And yeah, I did. What you actually need to change in essence in this formula you are seeing on the board is just that wherever you see n, change it to a summation of f. And wherever you see maybe like x bar, x squared, or x, then tends to attach f with them, because we are having many and a lot of distribution, a lot of data. So we have to multiply their frequency with them. As a single data might repeat itself more than once. So we have to multiply the amount of time it repeats itself with it. So that's why we're multiplying f. So which means for this one, what we're including is just f. You understand? Don't forget to find the x bar of that in that case. Since we are considering a group data, x bar will be equals to the summation of fx over summation of f, in case it is a distribution that is listed out. So make sure you find the x bar using the appropriate formula of it. You understand? However, we are still considering population variance. Perfect. So now for these, we are including f here. So you multiply f with x squared. After you squared each of the individual distribution, then you multiply the frequency with it. Now instead of n, I'm going to change that to summation of f. Likewise this, I almost forgot that. So this will be summation of f. Summation of f. Perfect. Now instead of n, we have summation of f. Okay, just keep on following the logic. Summation of f. Now instead of n here as well, we're going to have summation of f. So we have summation of f. Now on to the third one. So instead of x squared alone, so we're going to include f. Now for this, instead of summation of x, we're going to include f. So that's just a difference between the formula for the group and ungroup. Now for this, instead of n, you turn to summation of f. Likewise this, summation of f. So we have the summation of f, the summation of f. Now for this, get rid of it, put f, or summation of f rather. Okay. So we have the summation of f. Now f is going to be fixed here. Now f will also be here. And lastly, f, summation of f will be here. So that's it. So that is the difference between the population variance for the group and ungroup data. So know when to use which. And those are the formulas that helps us to find the population variance for both group and ungroup data. Now what about the sample variance? What is the formula that helps us to do that? Let's look into that. However, before I discuss the sample variance, let me just use that opportunity to branch the standard deviation. For the population standard deviation, keep that in mind that that is just equal to the square root of the variance. So we often denote this standard deviation with the symbol sigma. Since it is the square root of variance, definitely it will be the square root of sigma squared. And since square root cancels square, so this square will be get rid of and will be left over with sigma. So standard deviation is equal to sigma, which is square root of sigma squared. Are we together? Exactly. So that's how we got that. So this means if you have to find standard deviation, just root all this stuff right here. You root them entirely. After you got the entire answer, then you just find the square root of it. And that's it. So keep that in mind. Perfect. Now we can move on to the sample variance. So for the sample variance, so we often represent variance sometimes as var x or just var. Understand? Now, there's one thing I actually want to say. If the question of your lecturer doesn't specify what kind of variance you have to find, then I would suggest you find the population variance. Just use the formula for the population variance, as that is the most often used in most cases. We use that sample variance when we are dealing with hypothesis testing. Hypothesis testing. Let me do it again. hypothesis testing. You understand? So that's when we'll be selecting maybe some part of a distribution to just run a test and see what the results will be. You understand? But if they are specific, then you also know that this is the one you have to use, this one you have to use. For the sample variance, we know that with S squared. So the difference is just that for the first formula, that's going to be equal to the summation of x minus, but this time again, it won't be x bar. It's going to be the sample mean. Though sample mean and population mean, they gives us the same result, but the symbol we use to denote them is different. Sample mean, we use a symbol called mu. So that's going to be x minus mu, which is the mean, typically the sample mean, all squared, and divided by, for that of the population variance, we use n, but for the samples, it will be n minus 1. And that is for an ungrouped data. Perfect. Now, the next formula is such that it's equal to the summation of x squared, the minus n multiplied by mu squared, then entirely divided by n minus 1. Perfect. Now for the third one, for the third formula, that's equal to the summation of x all squared, the minus summation of x all squared divided by n, then entirely divided by n minus 1. Now for the fourth formula, then I will recommend that don't use the fourth formula for the sample mean or for the sample variance. And this is because it won't work. You understand? It won't work. So these three formulas are the most recommended one whenever you're dealing with the sample variance. In fact, this first one is the one I would suggest using in all cases, except the situation whereby you are given the sample mean, the summation of x squared, then the value of n. Otherwise, continue using this. So that's it for the sample variance for an ungrouped data. So for the group data, just like before, we just need to include f. So this is going to be the summation of f. Now this, instead of n, so instead of n, we are just going to replace it with summation of f. Perfect. So we have the summation of f. Perfect. Now instead of n right here as well, we're going to have summation of f. Summation of f. Now instead of this, f will be there. Now instead of n, that will be the summation of f. Okay, perfect. So we have the summation of f. Summation of f times mu squared and so on. Now f will be here. F is going to be here. Now instead of n, we have summation of f. N summation of f. And we have summation of f. And so you have all the necessary formulas you have to be familiar with to succeed in dealing with problems involving sample and population variance for both group and ungrouped data. So just like before, like we said, standard deviation is simply the square root of the variance. For a sample standard deviation, we denote that symbolically with the symbol s, since it is the root of sample variance. So the root of s squared is simply s. So we can find the root of all this entire expression, and we have our final answer. So that's it. Okay, just bear with the writing, and that's it. So now let's try to go over some examples to at least apply what we have learned into produce. Example number 1. Considering the distribution on the board, find the variance and the standard deviation, respectively. Now, as you can see, this distribution is an ungrouped data. So to find the variance, it's recommended for our work to be very, very neat. Let's construct a frequency distribution table. However, it can be done in the other way around, since it is not specified to construct or to arrange data using a frequency distribution table. So we need the mark, which is given, the frequency, fx, which will give us the mean, then x minus x bar, and that's it. Okay, so we have x fx, then x minus x bar. Perfect. So we are going to be considering using the population variance formula in this video. So while constructing a frequency distribution table, we have to arrange the distribution in ascending order or descending. So we have 3, 6, 9, 10, 12, 14. So I have to increase this. No, I'm still using white color, but let's continue. So the frequency is just 1, 1. They repeat themselves just once. Okay, fx will still be the result back. 6, 9, 10, 12, 14. Perfect. Now let's find the population mean. Population mean is simply equals to the summation of fx divided by the summation of f. So let's add the fx together. So what would that be? 3 plus 6 is 9, 9 plus 9 is 18, plus 10, 28, plus 12 is 40, plus 14 is 54. So we have 54. Now, how about the summation of f? So as you can see, they are just 6 in number. Summation of f will be nothing but 6. So therefore, the x bar, which is simply the population mean, will be 54 divided by 6. And 6 in 54 gives us 9. So x bar is simply 9. And that's it. So now let's find x minus x bar respectively. So 3 minus 9 gives us negative 6. So we have minus 6. 6 minus 9 gives us negative 3. Minus 3. 9 minus 9 gives us 0. 10 minus 9 gives us 1. 12 minus 9 gives us 3. And 14 minus 9 gives us 5. The goal at this point is to find x minus x bar all squared. We need that. Understand? So 6 squared, negative 6 squared gives us 36. Negative 3 squared gives us 9. 0 squared is 0. 1 squared is 1. 3 squared is 9. 5 squared is 25. We need a sum, so we can add that up. So 36 plus 9 plus 1 plus 9 plus 25. That gives us 80. Now we have everything we need to find the variance. So sigma squared, let me use different color. Sigma squared is equal to the summation of x minus x bar all squared divided by the summation of f, which is the same as n in this time around. You understand? Now, since f is just 1, 1, we really don't need to do f x minus x bar. You understand? Besides, it's an ungrouped data. We are the one that tried to group it using a frequency distribution theory table. Okay, so sigma squared gives us 80 divided by the summation of f is 6. So that's 80 divided by 6. So if I type that, go 13.33. 13.33 to 1 decimal place. Now, what about the standard deviation, the population standard deviation? So SD, or what I just said, sigma, is equal to the square root of the variance, which is square root of 13.3. So if we root 13.3, we should have 3.647. Let's say 347 to 3 decimal place. And that's how to easily find the standard deviation and the variance of an ungrouped data. Now, it's important for you to understand what a standard deviation means in Excels. Standard deviation helps us to understand the interval, how set of numbers, how they differ. When standard deviation of set of numbers is very less, it means those numbers are very, very close to themselves. While when the standard deviation of set of numbers is very high, that it means those distributions are far away from themselves. You can think about it. You can test that by using, let's say we have 1, 2, 3 as a distribution, and let's say we have 2, 8, 10 as a distribution as well. You'll see that the standard deviation for this distribution will be less compared to this one. That shows that the first set of numbers is very close to themselves compared to the second one. And that's what standard deviation helps us to understand. And let's consider finding the variance and standard deviation of a group data. Considering the frequency distribution tally table on the board, feel free to pause the video and find the standard deviation and the variance. So just like before, we are going to consider using the population variance formula. It's actually a population. You can see we are given everything entirely. So the first thing first is to find the value of x, which is the class mark. For a group data, to find a class mark given the class interval, all we need to do is to add these two values and divide by 2. Often case we call this one the lower limit, while this is called the upper limit. So 0 plus 4 divided by 2 gives us 2. 5 plus 9 divided by 2 gives us 7. 10 plus 14 divided by 2 gives us 12. And 15 plus 19 divided by 2 gives us 17. And lastly, 24 plus 20 divided by 2 gives us 22. And that is a class mark. Now to find fx, or the frequency times the mark. As you can see, 2 repeats itself 3 times. Then for all other distribution of all other marks, as you can see, they have the number of times they tend to repeat themselves. So we have to multiply them to have their fx. So 3 times 2 gives us 6. Now what about 6 times 7? 6 times 7 gives us 42. And 8 times 12 will give us 96. Let me confirm that. Yeah, 96. So 4 times 17, that should be 54. 4 times 17, okay, that's 68. 68. And 3 times 22, we got 66. And that is fx. So at this point, we need to find the population mean. So to find that, we need the summation of f. Likewise, the summation of fx, summation of f, and the summation of fx. So what is summation of f? Let's add that up. 6 plus 42 plus 96 plus 68 plus 66. So I got 278. And for the summation of f, 3 plus 6 plus 8 plus 4 plus 3 goes 24 for that. So we know that the population mean x bar is, okay, don't let me write it there. We are going to use a space. X bar is simply equals to the summation of fx divided by the summation of f. So summation of fx is 278 and summation of f is 24. So 278 divided by 24. That gives us 11.58 to 2 decimal places. So that is the x bar. Now we need x minus x bar. Now for this to give us a whole number and not decimal continuously, and for the solution to be much more in a brilliant way, I would like to approximate x bar to the nearest whole number. In this case, it will just be 12. So now I'll be using 12 to find x minus x bar. So I also need x minus x bar squared. Now keep in mind, in your classwork or assignment or test or examination, then I would suggest you keep on using this or whatever you have as a final answer. You understand? It's statistic. Statistic is what is the main next sense or the basic idea behind the course entirely. It's deal with large number of things. So you dealing with decimal numbers is not a bad idea. You understand? Perfect. So 2 minus 12, that gives us minus 10. 7 minus 12, that gives us minus 5. 12 minus 12 gives us 0. 17 minus 12 gives us 5. And 22 minus 12 gives us 10. Now we need to square them. 10 squared is 100. Negative 5 squared is 25. 0 squared is 0. 5 squared is 25. 10 squared is still 100. Now we need to sum them up because we need the summation of x minus x bar. I almost forgot. Since this is a group data, we need to find fx minus x bar. So we need fx minus x bar squared. So for the frequency 3, we have 100. 3 times 100 gives us 300. 6 times 25, that should give us 150. But I will confirm that 6 times 25, yeah, 150. So 8 times 0 gives us 0. Then we have 4 times 25 gives us 100. And finally, 3 times 100 we say have 300. So we have the fx minus x bar column fixed or filled up properly. Now we can find the sigma squared. We said for a group data, sigma squared is simply the summation of f times x minus x bar squared, then divided by the summation of f. So since the summation, okay, we haven't added up, so let's add. Summation of x minus x bar squared, that gives us 300 plus 150 plus 100 plus 300. So we got 850 by that. For those of you wondering what I'm adding all the values in this column. So that will be 850 divided by the summation of f. We've got that to be 24. So divided by 24. So 850 divided by 24, I got 35.42. So 2 decimal places. And that is our sigma squared, typically the population variance. Now that we have the population variance, it's easy for us to find the population standard deviation. So SD or sigma is equal to the square root of the variance or of sigma squared. That's simply the square root of 35.42. And if I use square root 35.42, square root of 35.42, then I got 5.95. And that is the standard deviation of this distribution. And that's how to easily find the standard deviation and variance of group and ungroup data. I hope you find this video helpful and understandable. Feel free to subscribe if you want to. Like I said at the beginning of this video, I'm going to show you how to find what we call the coefficient of standard deviation and that of the coefficient of variation. So whenever you have to find the coefficient of standard deviation, what you have to find, next sense, is to find the ratio of the standard deviation to that of the population x bar. So which means for this distribution, the coefficient of standard deviation would be 5.95 divided by the x bar. We approximate it to 12, divided by 12. That's 0.495. So that's the coefficient of standard deviation. Now for the coefficient of variation, the goal is just to multiply your result by 100. And that will give you the coefficient of variation. So it's 495 times 100 got 49.5%. So the coefficient of variation, which is often written as C over, is equals to 49.5%. So that's it. And I hope you find this helpful once again. Thanks for watching. Bye for now. So this is your exercise. Feel free to share your solution via the comment section below. Consider finding the population variance and that of the standard deviation, likewise the coefficient of standard deviation and that of the coefficient of variation. Thank you. Bye for now.